Hi, welcome to my video on the review of implicit differentiation. And as in all my reviews, you can treat it as a quiz. And this quiz is marked at a 42, so give yourself a score for each question, total up the pages, and your mark hopefully is 42 out of 42. Whatever score you get, if you score it, put it over 42, divide 42 into this numerator, get a decimal, move it 2 places to the right to get a percent. Here we go. Find dy dx if y cubed plus 3x to the fourth, y squared minus 2x to the 5 equals 6. So we have to do a ddx. So a ddx on y cubed is 3y squared. And ddx on a y will give you dy dx. And we have the derivative of 3x to the fourth y squared, and that's a product. So the derivative of 3x to the fourth is 12x squared. 12x cubed, almost made a little error there. 3 times 4 is 12, and decrease the 4 by 1, times g plus 3x to the fourth. Derivative ddx on the y squared is 2y, and we get a dy dx. And the derivative of a negative 2x to the 5, 2 times 5 is 10, x to the 4. And the derivative of 6, which is constant, is 0. So let's simplify that. So we have 3y squared dy dx plus 12x cubed y squared. And we have a 6. 3 times 2 is 6, x to the fourth y dy dx minus 10x to the fourth equals 0. Now we're solving for dy dx, so let's isolate the dy dx's. So we have 3y squared dy dx plus 6x to the fourth y dy dx equals 10x to the fourth minus 12x cubed y squared. So I moved this one first because I'm going in descending order of the x's, because we have two variables there. I'm going with the x's first and then the y's. So we have to factor dy dx, and we take it out and we get 3y squared plus 6x to the fourth y. So the right side won't change. And now we get dy dx is equal to 10x to the fourth minus 12x cubed y squared, and that's divided by 3y squared plus 6 x to the fourth y. Now if we want, we can have all of this in descending powers of x first, so it's 10x to the fourth minus 12x cubed y squared, and we're going to have 6x to the 4y plus 3y squared. So if you have that answer, this one, or don't have to be in descending powers of x, you have 7 marks. So what I did was give 4 marks for this step, and I gave 1 mark. You simplified it, and if you did, great, you gave yourself a mark. And if you group them together, isolate them and group them together, you get another mark, and when you divide, you get another mark. So that's 7 marks altogether. Hopefully you have the right answer. Number 2, find the value of dy dx at x equals 2 if 3x squared plus 5 ln y equals 12. Well, to find the value of dy dx, we need the point that it occurs at. So if x equals 2, So I'm going to sub x is 2 in here. So 3, 2 squared plus 5 ln, if I can spell it right, ln y equals 12. So we square first and then multiply. So 4 times 3 is 12 plus 5 ln y equals 12. So we're solving, we're trying to find the coordinates of the point. So the point, we have x is 2, we need to find a y. So we're going to solve this equation for y. So 5 ln y equals 12 minus 12. So 5 ln y equals 0. So that means that ln y is 5 divided by 0 is 0. And the ln, that we can change it, that's log, L-O-G, base is e, y equals 0. So the base exponent number, so that means e to the 0 is 1. So that means the point is 2 comma 1. So now let's take this equation, which is 3x squared plus 5 ln y equals 12. And let's do the derivative of this equation, which is the slope of any point on the curve. So the derivative here, d dx of this is 6x. And that's a constant, so it's a 5. Derivative of ln y is 1 over y. And the derivative of y is dy dx. And the derivative of a constant is 0. So we simplify that, we get 6x plus 5 over y dy dx equals 0. So 5 over y dy dx equals negative 6x. And we multiply, we have a fraction there, so let's multiply by each side by y plus 5. Sorry, y over 5, my mistake, y over 5 reciprocal. So they cancel out. So I get dy dx is equal to, that's 6x. Okay, so that gives us a negative 6xy over 5. So that's what the slope is. So that means that the slope is the derivative, so it's a negative 6xy over 5. So let's take the point. So the point is 2 comma 1, and we sub 2 comma 1 in here. Negative 6, x is 2, y is 1 over 5. So that gives us a negative 12 over 5 as our slope. So the equation, or sorry, the value of dy dx is, the slope is negative 12 over 5. I'm going to say, I'm going to want to get the equation of the tangent then, but I didn't get the value. So the slope, which is dy dx, is, remember, dy dx is the slope. And I didn't have to say that, but the slope, or dy dx, is negative 12 over 5. So if you did all that correctly, then if you found what y is, give yourself 2 marks. If you call it the point, give yourself another mark. If you worked out the derivative of this equation correctly here, you give yourself another mark, so that's 4. If you worked out the worked it through to get the 6 over 5, you give yourself another mark, and you subbed it in, you have another mark. And so there's 2, 3, 4, 5, 6, and all the way along the line. So we got the point. Oh, I gave 2 for doing the derivative correctly. So 7 altogether. So again, 2, 3, 5, 6, 7. And total up here. page. Okay, let's do another one. Find the equation of the tangent to y squared plus 4x equals negative 4e to the 3y at negative 1, 0. So to get the equation of the tangent, I need to find, I have the point, so I need to find the slope. So the derivative is the slope of the tangent. So let's get d dx on this equation. So 2y, or y squared becomes 2y dy dx. Derivative of 4x is a 4. Derivative of negative 4e to the 3y. Negative 4 is a constant, so leave that there. So the derivative of e to the 3y is e to the 3y. And because of the chain rule, derivative of 3y is 3. And the derivative with y is dy dx. So we have that. Now we have to get the slope up, which is dy dx. So we have to, let's tidy this up first, because if you tidy it up, it makes it easier moving forward. So that gives us a negative 12e to the 3y dy dx. So that's tidy. So we need to find dy dx as the slope, so we group them together. So 2y dy dx plus 12e to the 3y dy dx is equal to negative 4. So the dy dx is grouped together on the left. The negative 12 becomes positive, and 4 goes to the right, and the negative. So we'll take the dy dx out, and we get 2y plus 12e to the 3y equals negative 4. So that means dy dx is equal to negative 4 over 2y plus 12e to the 3y. And we can simplify this, because if you simplify it, you make it easier. So I'll just do it here. And we get 2 as a common factor. So we take 2 out. So 2 is a common factor, so when we take it out, we will get 2 divided into negative 4 is negative 2 all over y plus 6e to the 3y. So the derivative is the slope of the tangent, so that means the slope of the tangent is negative 2y plus 6e to the 3y. Now, if we have the point that we have, if we sub in the values of x and y into this point, then we'll get the slope of the tangent. So we have no values of x, so we put 0 in for y. So we go negative 2, y is 0, plus 6e to the 3 times 0. So that's negative 2 all over. So 0, so this is 6e, 3 times 0 is 0, so that's negative 2. And e to the 0 is 1, so that's a 6, so that's negative 1/3. So the slope of the tangent is negative 1/3. So the equation is y equals mx plus b. So we have a point and a slope. So y is 0. The slope of the tangent is negative 1/3. X is negative 1. So that gives us the y-intercept. So that's positive 1/3 plus b. So b is negative 1/3. So the equation of the tangent is, the slope is negative 1/3 times x plus the y-intercept is negative 1/3. So that's the equation of the tangent for at the point negative 1, 0 on this curve. And we have 9 points here. Or sorry, yes, 9 points. I got 9. So let's say where I would assign them. So if we did the derivative correctly and simplified it, then if you did this step, I give yourself 3 marks for the derivative and the simplification. If you group them together and isolate them, give yourself a mark. And if you divided and simplified, so if you divided, you get a mark, and if you simplified it, you get a mark. Found the slope at the point, you get a mark. You found the y-intercept, you give yourself a mark, and if you found the equation, you give yourself a mark. So 9 marks altogether for that question. And hopefully everything is going okay. So we have another question to do now. Find d squared y and dx squared as a rational expression in terms of x and y if 4x squared minus 3y squared equals 9. So d squared y and dx squared is the second derivative. So let's find the first derivative first. So d dx on 4x squared is 8x. And we have derivative here is 6y. But because we do d dx on the y, we have a dy dx. The derivative of 9, which is constant, is 0. So that gives us negative 6 dy dx is equal to negative 8x. So dy dx is negative 8x divided by negative 6y. And the negatives cancel out. Negative divided by negative is positive. 2 is a common factor, so we get 4x and 3y. So that's the first derivative. Now, if we do the derivative of this function, so if we do d dx on each side of this equation, we get d squared dx squared, which is the second derivative. So this is f and g, so the derivative of 4x is 4 times g, which is 3y, minus 4x times the derivative of 3y, which is 3 dy dx, all over the denominator squared. So 3y is squared. So that gives us 12y minus 12x dy dx all over 9y squared. Now, that's the first derivative is 4x over 3y. Second derivative is right here, but we want it as a rational expression in terms of x and y. So that means we have to, this is dy dx, so 12y minus negative 12x, and dy dx is right here, so it's 4x all over 3y over 9y squared. So when we simplify this, now we can cancel out the 3's if we want here. 3 into that goes 4. So that gives us 12y, and that's a negative 4x times 4x is 16x squared over y divided by 9y squared. So I multiply these two first. So the numerator is simplified, denominator is simplified, but we have a complex fraction. So I need to get rid of this y here. So I'm going to multiply the top and the bottom by y. So 12y times y is 12y squared. Multiply by y here, and I get a negative 16x squared. Multiply by y here, and I get 9y cubed. So that's doing the double derivative as a rational expression, which means a fraction in terms of x and y fully simplified. And there's 9 marks here. So if you did the derivative correctly, right here, then you get 3 marks. If you solved it correctly to here, you get another mark, so that's 4. If you did the derivative here, you get 2 marks. And if you simplified it down here, you get another mark. And if you went to here, you get another mark. So hopefully that's 3, 4, 8 marks altogether if you have this final answer. So notice I did the first derivative, did the second derivative, and I substituted the first derivative into place with x's and y's and simplified. Excellent question. And the last question to do is if x squared plus 9 equals 2xy, find the value of x times y prime plus 2 times, or sorry, x times y double prime plus 2 times y prime. What value are we going to get? Well, this question works out very nicely, and it's a good question to do in dealing with implicit differentiation. So y prime is the same as dy dx. Y double prime is the same as d squared y over dx squared. So first derivative, second derivative. So the first derivative here gives us, we're going to get d dx on this, so we get 2x. Derivative of 9 is constant 0. And we got a product, so this is negative 2x is the f, and that's the g. So the derivative of negative 2x is negative 2 times g, and we get negative 2x times the derivative of y, which is, derivative of y is 1, and we get y prime. It could be dy dx, but we're going with y prime this time. So simplify that, I have 2x plus a 0 equals negative 2y and a minus 2x y prime. So we're solving it for, we want to get what y prime is. So this 0 we can ignore, so we get 2x y prime equals negative 2x minus 2y. So I took the y prime and moved it to the left and made it positive, moved it 2x over and made it negative. So that means that y prime is equal to negative 2x minus 2y divided by 2x. And that means we can take out the 2 or the negative 2. So let's take out the 2. So 2 outside of negative all over 2x. So that means that y prime is negative x minus y over x, because the 2's cancel. The 2's cancel, not the x. Now that's what y prime is. So what is y double prime? Well, y double prime is double derivative, so we'll do the derivative on this quotient. So that means this is the f and this is the g. So the derivative of this numerator is d dx is, that's a negative 1. Derivative of negative y is a negative 1 y prime. Again, it could be dy dx, but we're doing the derivative of y, so it's a negative 1 y prime times the g, which is the x, subtract f, which is, this is f, times the derivative of g, which is x, derivative of x is 1, all over the denominator squared. So y double prime, simplify this, we get negative 1 times x is negative x, and we get a negative x y prime, and we got a negative 1 times this binomial here, so it's a positive x, positive y, all over x squared. So y double prime. The x's cancel out, so we get negative x y prime plus y over x squared. So now we know what y prime is in terms of x and y, and y double prime has a y prime in it. So that means that y double prime is negative x, and y prime is negative x minus y over x plus y. So what I'm doing is I'm making y prime in terms of x and y. So we have the multiplication here, so the x's cancel out. So negative 1 times negative x minus y is x plus y plus that y over x squared. So that's x plus 2y over x squared. So we have y prime in terms of x and y. We have y double prime in terms of x and y. Now we got to look at what this function is saying here. So let's see. Let's write down, we have x, y double prime plus 2y prime. So that means x and y double prime is negative x y prime and 2. So y double prime, there it is. Oops, y double prime is, I wrote my mistake, sorry about that. Y double prime is x plus 2y over x squared. And y prime is negative x minus y over x. So the y double prime is in terms of x and y. Y prime is in terms of x and y. Now we simplify this and let's see what we get. So this x cancels into this one. So that's x plus 2y over x. And this is plus 2 times that is negative 2x minus 2y all over x. We have a common denominator, which is x, so we add up the numerators. So the y's cancels out, so that gives us x minus 2x is negative x, and that gives us, they cancel, it gives us negative 1. So we worked that through carefully, except for my little error here, putting the y prime in. I worked all this out to put all x's and y's in, but so that shouldn't be right there. So that value is negative 1. So it's a good little algebra question, good little trig question, good little differentiation question. Perfect. Good math on this problem. And again, if you, it's 11 marks, if you put the 11 marks, if you do the derivative here, you get 2 marks. If you solve it to here, you get a mark. And I'm just going through and assign the marks. So there's 4 marks altogether. If you did your derivative correctly here, you get 2 marks. If you simplified it down to here, you get another mark. If you subbed in the y prime and worked it out to here, you get another mark. So the marks are going through like that. And when you sub that in here correctly, you get another mark. When you simplify it, you get a mark. And when you get that final answer, again, 11 marks altogether. So I just distributed. The reason I distributed the marks through, so if you make a mistake down here, you get credit for all this work. Again, it's just my way of doing it. I give you credit for what you get right at the beginning and just don't give you a 0. So it's 11 marks for that question. So that brings us to the end of this video. And again, if you have total up your pages and your mark is, put your mark over, like at the beginning, put your mark over 42. And hopefully you have 42 out of 42. And barring some errors. Everything is, you understand the unit on implicit differentiation as far as I can, my videos to help you understand. Again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.